Welcome to this special episode of Frequency Matters, the Art from Microwave Update series. I'm Pat Hindle, and today we're going to discuss automotive safety systems and autonomy applications for radar sensor technology. This is part one in our three-part series on automotive radar sensors. Here to discuss this with me is Jan Podkamien, Vice President and Head of Automotive at Vayyar. Welcome, Jan.
Hi, Patrick. Welcome, everybody.
So what trends are you seeing in the evolution of radar sensors for next generation ADAS and vehicle autonomy as you've developed this 4D radar sensor technology?
What we see today is a shift from the traditional corner radar towards imaging radars. Basically, a much larger antenna array that creates a high resolution and a wider field of view and more longer ranges, while providing imaging capability, because you are no longer only interested on getting some awareness about something in front of you. You actually really want to have some much more dense and rich information to be able to distinguish between elements. So if in traditional days you just needed something which was a little more sophisticated and ultrasonic, or maybe a little more longer on distances, today you want something which would be complementary to a camera, and even in dark hours or in tough weather conditions, you want actually the radar to start becoming almost like a full replacement of cameras. So you need to have something which is much more closer to an imaging ability than just awareness like the traditional radars. We see that both outside of the car for ADAS. We see that also for motorcycles, because the speeds and because of the maneuvers and the tilts and the low and limited space for form factor due to the motorcycle dimensions, as well as for in-cabin monitoring, where at the end of the day, also there you want to have an imaging capability and have a platform that will start allowing both inside and outside of the car developing solutions on top of image ability.
So how are your 4D radar sensors meeting these new challenges, and how do they compare to the previous generation of radar sensors?
So Vayyar is a pioneer in MIMO, massive MIMO radar on chip. Okay, we didn't invent radars. Those are existing since World War II, and they're perfectly working okay. In the heavy military domain, you have huge systems with many antennas, but that's not really fitting to our automotive. Okay, the idea is how you can take that ability, miniaturize it to as small as possible, while not compromising on performance. The magic is the integration. So we managed to integrate 72 transceivers into a single chip solution with all the computing inside. Those are split into ultra wideband and millimeter wave. If we focus on the millimeter wave, 48 transceivers on a single chip with all the computing inside of the chip. So it's basically not a system on chip, it's a full massive MIMO radar on chip. This is one. So it doesn't really require multiple radars, front ends. It doesn't require a heavy processor or FPGA outside. Everything is done inside of the chip. This is one of the things we are doing very differently from the whole industry. The second main difference, I think, is that we are a fabless semiconductor selling the chip, but we actually are a full system solution. So we are designing the antennas, we are designing the array, we are designing a full automotive grade, ready for production reference design, which we provide as part of the engagement to our partners. And we also do the software stack, the whole RF low level algorithms. So in theory or in practicality, we basically sell the chip, but we provide a full solution that allows our customers and our partners to start engaging from day one and integrating and start developing solutions on top of the system. So they don't need to, it's not the traditional way. At the end of the day will be, you need to buy a chip from someone, you need to have a design house for the software, another company that will do the PCB, and you pray for everything working together. In Vayyar's approach, and this is a philosophy thing also, we believe that having in the same building all the expertise, and we know everything inside out, we know how to optimize for various use cases and optimize the whole system as a system, a global optimization and not just a local optimization of subcomponents, which eventually maximizes the whole performance of the system, allowing that high integration of the building block to really provide the maximum of what it can.
That's a great way to approach it. So what are some of the key performance specifications that are used for these advanced radar sensors and the design differences?
So we have, in this radar domain, you have the usual suspicious. So one is the angular resolution, okay? We are talking about a few degrees, 1-2 degrees of angular resolution. So this is a very significant improvement over existing radars. The second one is the field of view of the antennas. So we can, in short ranges inside of the vehicle, or for short range for parking assistance, we can get almost to 180 degrees horizontal field of view. We can play with the elevation field of view to maximize the distances, and we manage even to squeeze into a single chip the ability to run from 0 to 300 meters. So it really covers all the range of the short, medium, long range radars today, with the ability to have the 180 degrees for the short ranges, while in slow speed and focusing on the distance. All of that in high resolution, all of that compiled in a single software image running simultaneously and analyzing all the elements. So it's a nice improvement on some of the KPIs of the industry today. Needless to say, it's really saving cost, right? It's a silicon, so if you think about the number of components you are having now, instead of 4, 5, 6, 7 components like some of our competitors, by definition, the whole system is much cheaper.
The increasing density of the urban jungle creates a unique range of safety challenges, but a higher level of protection normally comes at a price. Vayyar's platform, powered by a single 4D imaging radar RFIC, delivers 360-degree coverage with just 2 to 4 sensors, significantly cutting the costs of sensor units, wiring harnesses, and maintenance. Each sensor combines an ultra-wide 170-degree field of view, along with pinpoint accuracy from 15 centimeters to 30 meters for multiple applications with no dead zones. Valet parking requires precise detection, tracking, and 4D mapping. Vayyar's platform generates high-resolution point cloud imaging, enabling drivable path detection and identification of occupied and available parking spots. It also detects obstacles such as poles and shopping carts even before a vehicle enters a parking spot, preventing low-speed collisions. Unrivaled precision also supports valet parking in challenging scenarios such as 45-degree spaces. Automatic parking assist demands high resolution and accurate detection to support entry into tight spots. Vayyar provides the required reliability with just 2 to 4 RFICs. Leaving a parking space can be a challenging maneuver, as the driver's line of sight is often obstructed. The platform's ultra-wide field of view enables early detection of cross-traffic, supporting driver alerts and even autonomous exit. It also detects pedestrians and cyclists at far greater distances than ultrasonic sensors, supporting earlier alerting and active safety applications. Detecting vulnerable road users in parking lots is especially challenging, as they may suddenly emerge from behind or between vehicles. Vayyar's 4D imaging radar platform enables early detection of even slight movements, ensuring reliable sensing in complex scenarios. Ultra-short to mid-range capability provides exceptional value for OEMs. Just 2 to 4 sensors provide 360-degree coverage and high-resolution imaging with effective overlap and no dead zones. The platform is the cornerstone of best-in-class applications such as valet parking, obstacle detection, automatic parking assist, and autonomous exit. The uniquely multifunctional platform also enables the consolidation of multiple functions such as advanced parking assistance and short to mid-range ADAS applications into a single hardware unit. It drives substantial direct and indirect savings while providing unrivaled levels of accuracy and reliability. Vayyar's RFIC is AEC-Q 100 compliant and ASIL B ready, designed to support SOP 2022 programs. It's the clear choice for a new era of urban driving.
That was a nice demo. Thank you very much. So when do you see these 4D radar sensors being widely adopted in cars and other vehicles?
So clearly I cannot get into any commercial secrets, but from what already is public, Piaggio Group motorcycles will launch early 2022 using Vayyar 4D imaging radars for ADAS, which is the rider variation for ADAS. And you may expect to see more vehicles on the road very soon, both inside and outside of the car.
Excellent. We look forward to having those advanced features in our vehicles. Thank you, Jan, for discussing the new automotive radar sensor technology that is evolving ADAS and autonomy solutions. We appreciate your insightful discussion, and we look forward to our next episode on in-cabin sensing applications for automotive radar. Thanks, everybody, for watching.